Hi everyone, and welcome to our last day of Unit 4 notes about congruent triangles. If two triangles are congruent, then we know that every pair of their corresponding sides and angles are congruent. So if I told you that these two triangles right here were congruent, then you would know, for instance, that this angle and its corresponding angle have to be the same size. In geometry class, we call that CPCTC, or corresponding parts of congruent triangles are congruent. You've got to know that the triangles are congruent using one of the big five postulates first, and then you can use CPCTC as a reason in a proof. Here are a bunch of other reasons that we're going to be using in our proofs that we do today and in class. You may need to pause the video and write in some of the ones that are missing, like reflexive property, perpendicular, midpoint, bisector. Add those in, those definitions, because we're going to be using them in some of the proofs we do. After you've unpaused, you can scroll on down, or turn on down. We're going to actually do a couple proofs. Anytime you're given information, always put it in your picture. So M is the midpoint of HS and GT. Here's M. From the definition you wrote down up above, we know that a midpoint divides a segment into two equal pieces. So M is going to divide HS into two pieces and GT into two equal pieces. So when I start to actually complete my proof, the given will be the first thing that I write down, my given information. GM is congruent to TM. GM and TM, the reason I marked those two the same size is because the midpoint cut them in half, or it cut GT in half. So this is just me using the definition of a midpoint. Anytime you go from a vocab word to some word or some math that represents that vocab word, that's our clue that we might be using a definition. We use it again for number 3. HM and SM were the same size. The reason I put those markings in is because I saw a midpoint dividing a segment in half. So again, I've got the definition of midpoint being used. Next, angle GMH is congruent to angle TMS. So GMH is there, TMS is there. The reason I know those two are congruent is because they're vertical angles. So our vertical angle theorem says that all vertical angles are congruent. Finally, I'm proving triangles are congruent, so I'm going to use one of my big five postulates. The reason that GMH and TMS would be the same are because they have a side, an angle, and a side in common. SAS, SAS. So that's the big five theorem that I'll be using. In number 2, we see a little bit different kind of proof. So I'm starting out with a bunch of given information that is already marked in my picture. Now I've got some other stuff to add in. KLJ is the same size as MLN. The reason those two are the same as before, our vertical angle theorem. And now I'm diving in and proving triangles congruent. So I'm going to use one of my big five postulates. The reason that those two would be congruent, if I look at what they have in common, I see an angle, a side, an angle, a side. So that's why the two triangles are congruent. Now that I know the triangles are congruent, I can go back and say, oh, well, everything about them is going to be congruent, all their matching pieces. So KL matches up with ML. So since the triangles are congruent, those sides have to be congruent by CPCTC. We're going to save the rest of the proofs for class time. But we do want to look at kind of some more complicated sorts of triangles. So flip on over, we've got overlapping triangles. We can prove that overlapping triangles are congruent, and drawing them separately helps us do that. So here's an example. We were given triangle ACF, and it overlaps with, I'll do a different color, triangle AEB. So you'll notice that like where I kind of went over myself again, or the thing that those two triangles had in common, is angle A. Let's practice a few. I'll do number 1 with you, and then I want you to try 2 and 3 alone. Number 3 is going to be a question in the Google Doc that you do. Let's color code. So we've got triangles ABC. There it is, ABC, ABC, which I want to draw out separately from triangle DBC. So DC, DCB. So when I draw them out separately, the thing that appears in both of them, or kind of where I overlapped myself, they both have BC as their shared object. It's helpful to draw them out separately when we're trying to use information to write, congruent statements and postulates that prove them congruent. Separate and redraw the triangles. I'm going to do number 2 and then let you try number 1. I've got RT and SU the same for both of them. And then the directions also tell me I've got to look at RUT. So RUT and angle STV, or sorry, STU. So by kind of outlining the stuff they're giving me in that given, I can see my two triangles are going to be this green one, STU, and the red one, which is RUT. RUT. Now, we know that RT and SU are the same size, so I'll mark that. RT, SU. I also know that RUT and STU are right angles, so RUT is a right angle, STU is a right angle. And the place that they had in common, or where I kind of went over myself again, was down here at UT. The green triangle has UT, and the red triangle has UT. So when I say why they have to be congruent, I'm going to use one of my big 5. I see angle, side, side. Ooh, but I don't want to end up cursing. Luckily, this is a 90-degree angle, so I could use hypotenuse, leg. The other triangle also has a hypotenuse and a leg with the same number of markings. So HL is the reason the triangles are congruent. My congruent statement, okay, I've got triangle RUT congruent to, let's see, I've got R matching up with S. T and U were both the right angles, and then the pointy one over here was T, the pointy one over there was U. So RUT is congruent to STU. You try to separate out number 1. I'll give you a hint. The thing they're going to have in common is going to be that angle A. So ABY is one of your triangles. See if you can find the other one. And I'll see you in class with any questions that you might have.